Yeah, students, as part of our second unit, we will see the next topic, projections of plane surfaces. So here we are going to draw front view, top view, as well as if required when the plane is kept perpendicular to both the planes. Only in that case we are going to draw the side view also. So this is the part of second unit. We will see the content of this second part of this second unit. So orthographic projections, this is the syllabus of second unit. Now we are in the last topic of second unit, projection of planes. It includes polygonal circular surfaces inclined to one of the principal planes and perpendicular to other by rotating object method. So that is rotating the plane itself. So instead of rotating the axis line, that is another method, auxiliary plane method. So we are not using that. So instead of that we are going to rotate the object itself. So this is the content we are going to see now. So projections of planes. A plane is a two-dimensional object having length and breadth only. So its thickness is negligible. We are ignoring its thickness. And types of planes, there are perpendicular planes and also oblique planes. So oblique planes, it is of last case. The surface inclined to both reference planes. So, we are not having this part or content in our syllabus. So positions of planes, we are dealing with only perpendicular planes. Surface of the plane kept perpendicular to HP and parallel to VP. Surface of the plane kept perpendicular to VP and parallel to HP. And surface of the plane kept perpendicular to both HP and VP. Surface of the plane kept inclined to HP and perpendicular to VP. Surface of the plane are kept inclined to VP and perpendicular to HP. On the last case, oblique plane, surface of the plane kept inclined to both HP and VP. So this alone, that is this case alone is not there in our syllabus. So no need to worry about this case. And the first case, before starting the first case, we will see different planes. It is a square, rectangle, rhombus, rhomboid, and these are known as parallelograms. And this is triangle, and this is pentagon, hexagon. We have heptagon, octagon, and there are so many sides. So depending on number of sides, we can name that particular plane. And also we have trapezoid and trapezium. These are the regular shapes. These are the regular planes. So these are the points to remember while doing these problems. When the plane surface is parallel to HP, so the plane surface is parallel to HP. In that case, top view shows its true shape. So we can see the true shape of the plane only in top view and size. Therefore we have to draw the top view first, and then from there we have to go to next step. And when plane surface is parallel to VP, so when it is parallel to VP, only in front view we can observe its true shape as well as its size. So we have to start from its front view. So these are the two very important points you have to remember. So to start the problem, always you have to start with its true shape. So wherever you see, on whichever plane you see the either front view or top view, so in that plane, in that reference plane, we have to start the true shape. So in whichever plane you observe the true shape, from there you have to start the problem. So it's obviously the next view, the corresponding view will be a straight line. So only line you have to draw. So this is the first case. So when the plane kept perpendicular to HP and parallel to VP, so this is ABCD plane. It is in space now. So that is why we are notating this with capital letters ABCD. and on VP we can see its front view. So A dash, B dash, C dash and D dash, and its corresponding top view is A is visible, B is invisible. So B should be within bracket, and D is visible, C is invisible, so C should be within bracket. So its corresponding views on paper can be drawn like this. First draw the XY reference line. So VP and HP, this is the regular pattern, and this is the front view. So front view we can see A dash. So this view is front view, and from front view draw the projectors and draw a line. It should be thick line. So in a top view, right, in top view you can see only a line, right, only this part you can observe. So A is visible, B is becoming invisible, and D is visible, C is invisible. So you have to notate them in the same order. So this is the first case. And surface of the plane kept perpendicular to VP and parallel to HP. So in this case, so this is your VP and HP, and now this plane ABCD is the plane which is kept perpendicular to VP. So here the front view is a line and top view is the true shape, right? This true shape is observed on the top view. So in top view you have to draw its true shape, right? So this is A dash should be within bracket. A is invisible, B is visible in front view, D is invisible and C is visible in front view, and its corresponding top view is a rectangle, and ABCD all are visible. So you have to start with the true shape. So draw the true shape first, and its corresponding front view should be drawn next. So this is A dash, B dash and C dash, D dash, and when the plane surface kept perpendicular to both HP and VP. So in this case, so this is the plane surface. So only inside view you can see the true shape. So this is the side view, either left side view or in right side view we can see its true shape. So either you can start from left side view or right side view, in any view is fine. Suppose if it is asked to start with right side view, then you have to start with right side view. So right side view should be drawn on left side in your drawing sheet. So that is how you should start this problem. So ABCD, and A is invisible, right? A is invisible and D is visible. B is invisible and C is B is invisible and C is visible, and its corresponding top view is BA and CD. So VT is vertical trace and horizontal trace HT, and the view itself is the trace. So A, B, so traces are not required for our syllabus, so no need to worry about traces right now. So draw XY reference line, and you have CD is visible in front view, and obviously we have to start with the side view. I will show you that while solving a problem. So front view is a straight line, and top view is also a straight line. So B is invisible and C is invisible, and here in front view A and B are invisible. So that is the third case. And the fourth case, surface of the plane kept inclined to VP and perpendicular to HP. So in this case you have VP. So this is you have phi. Pi is the angle with respect to VP. So this is the notation we are using, and this is ABCD, and its front view, right? Its front view is a apparent view. It is only apparent view. So in this case, first while solving these type of problems, initially you should assume that it is parallel to VP. Now it is inclined to VP. First step, because we have to start with true shape. So that is why you should assume that this ABCD is parallel to VP, and you have to start from true shape and first draw the true shape itself, and then in second step we can tilt it to this pi angle and we can complete the projections. So that is how we have to start and complete these type of problems. And the top view is a line only, a straight line, and this is A, B, C, D. C and D are invisible, and XY reference line, and this is pi angle, and this is apparent view only. So this is not the true shape, and the top view is a inclined straight line, inclined line, right? And this is the side view. So this is the side view, and no need to draw side view since the true shape can be observed from the front view, right? So if side view is asked, and you can draw this side view, right? And next case, surface of the plane kept inclined to HP and perpendicular to VP. So in this case it is theta, we have theta, and at theta angle we have this plane. And here also, in this type of problems, while doing our problems, I will show you how to deal these problems. So this is the apparent view. So in front view you can see a line, in top view you can see the apparent view. It is not the true shape, it is not the true shape. So first step to start these problems, you have to assume it is kept parallel to HP. So on HP draw the true shape. In next step you tilt it to theta degrees. So that is how we have to solve this problem. I'll show you that. So this is the front view and top view. The front view is a line and top view is a rectangle. Sorry, it is a apparent view. It is apparent view. So this is the trace, and this is first problem. We will see how to solve these type of problems. A square lamina of side 40 mm has its surface parallel to and 20 mm above HP. So it is 20 mm above HP it is given. It is parallel to HP, right? So when it is parallel to HP, the true shape is observed in top view itself. So top view you have to draw the true shape. So you have to start this problem from top view. So draw its projections when one of its sides is inclined at 30 degrees to VP. So one side is kept at 30 degrees to VP. So it is not pi, but the side only kept at 30 degrees to VP. So pi, when you get the pi angle, then it is surface inclination. So surface inclination is different from side inclination. It is side inclination only. So you have to start the problem. It is only one step problem. Only side should be drawn at 30 degrees to VP, and that is how you have to start. So this is the 30 degrees. On 30 degree line you have to draw the square. So this is square, right? Square. So now this is the true shape itself. So top view you can see the true shape, and drawing square is very simple, right? So if you have drafter in just 30 seconds or 40 seconds you can complete a square on 30 degrees. So very simple. Use drafter effectively, that is very important. So here it is parallel to HP and 20 mm above HP, right? So 20 mm above HP. So above HP you measure 20 mm and draw a thin line. So from each point from top view you draw projectors till this thin line is 20 mm line. So you draw the projectors, and this point is A and this point becomes D. So D is within bracket. So this D is not visible, and B is visible, B dash, and C dash is also visible. From A dash to C dash, right? You should draw a thick line. So this is this maroon color, right? Those lines should be drawn with thick lines, right? So this is how you should solve this problem. And next problem, a hexagonal plate of 30 mm side has its surface parallel to VP and 20 mm in front of it. Draw the projections when one of its sides is perpendicular to HP. So here the one of its side is perpendicular to HP. So the orientation is very important, students. So in earlier case the orientation is at the side, one side is inclined to VP at 30 degrees, whereas here one of its sides is perpendicular to HP. So it is hexagonal plate. So hexagon you have to draw. So it is parallel to VP. So when the surface is parallel to VP, right, you can see the true shape only in VP, right, in VP, that is front view. So 20 mm in front of it. So 20 mm in front of it. So top view is observed at 20 mm from the XY reference line, that is the VP. Draw the projections when one of its sides is perpendicular to HP. So it is a standing hexagon. So it is nothing given, right? So the front view can be drawn, right, anywhere. So it is even you can draw above the line. So this is XY reference line. So now this side, right, this side A dash B dash is the side which is kept perpendicular to HP. So this is perpendicular to HP. So that is the condition given. So draw the projections when one of its sides is perpendicular to HP. Since it is hexagon, if you keep one side perpendicular to HP, it obviously the another side also will be perpendicular to HP. So no need to worry about another side. If it is a pentagon, you will have only one side that will be perpendicular to HP. Whereas here, since you have opposite sides are parallel, so another side also will be perpendicular. So no need to worry about it. Only the condition is satisfied here. So A dash B dash is perpendicular to HP, right? So you can notate, right, A dash B dash. So now the top view is in front of VP at 20 mm. So the plate is 20 mm in front of VP. So it is 20 mm, measure 20 mm, measure 20 mm. So measure 20 mm. So this distance from XY reference line to this C dash or B dash or D dash, so it can be any arbitrary distance. So nothing is mentioned in the problem. So you can take some convenient distance. You can draw at some viewable distance, right? So it should be at some appropriate distance. It can be any arbitrary distance, so no need to worry about it. But when you draw the top view, it is clearly given 20 mm in front of it. So you have to draw only like 20 mm. So that 20 mm should be considered. So A is visible, B is invisible. That should be within bracket, and F is visible, C is invisible, and C is within bracket, D is invisible, E is visible. So D should be within bracket. So now I have got this 3 points. So join all these 3 points with a straight line, that becomes the surface top view. So this is how you should solve this problem. So orientation is very important, and also the true shape should be drawn a regular true shape. It means that all sides should be equal, and the angle between any two sides should be equal. So you have to take care of drawing the true shape. So third problem, a pentagonal plane of side 30 mm is parallel to VP and perpendicular to HP. So it is parallel to VP and perpendicular to HP. Draw its projections when one of its corners is on HP. So the corner is touching HP. So that is very important. And the side containing the resting corner is inclined at 25 degrees to HP. So here it is parallel to VP. So obviously the true shape is observed, right? Is observed on the front view, right? So only above XY reference line you should draw the true shape, but the orientation you have to be very careful. So here one of its corners is touching HP, right? One of its corners is touching HP. So you have to draw only in this way, right? So this is at 25 degrees, right? The side is 25 degrees to HP, resting corner. So this is the corner and this is the side, right? So the side containing the resting corner is 25 degrees to HP. So draw 25 degree line and make sure that this corner is touching HP, and draw the regular pentagon and notate them. And now in front of VP nothing is given, no distance is given, so you can take some arbitrary distance, right? You can choose some arbitrary distance and you can draw it, right? So this is A dash and this is A, E, B, right? And B is invisible, that's why it should be kept within bracket, and C, D, right? So this is the top view. So this distance can be anything, right? So it is arbitrary distance. So this is how you should solve this problem number 3. And problem number 4, a hexagonal plate with 30 mm side has its surface perpendicular to VP. So here it is perpendicular to VP. When it is perpendicular to VP, it is obviously parallel to HP and inclined at 45 degrees to HP, right? It is perpendicular to VP and inclined at 45 degrees to HP. So the surface itself is 45 degrees. So it is a two-step problem. Surface is 45 degrees to HP. So it is nothing but a theta. Theta is given 45 degrees. Draw its projections when one of its sides is on HP and the corner nearer to VP is 20 mm in front of it. So the corner nearer to VP is 20 mm. So 20 mm distance you have to measure in top view, right? There you have to draw the draw the top view. So that is very important. So the orientation is clearly given, and this is a two-step problem, and you have to assume that the given plate, the given surface is parallel to HP in first step, and then in second step you have to tilt it to 45 degrees, right? So first you draw the 20 mm, and now this is the hexagon, right? This is the hexagon, and now this hexagon is nearer to this VP at 20 mm, right? The corner nearer to VP is at 20 mm, right? 20 mm, and the orientation is like this. So it should be at it is has its surface perpendicular to VP and inclined at 45 degrees to HP. Draw its projections when one of its sides is on HP. So it is very important. Please underline this statement. When one of its sides is on HP means, so this is the side, right? So with respect to this side, you are going to tilt the surface. That is obviously a straight line. So now you draw the line, right? You draw the straight line here. So this is your front view. This is simple front view. So this is now first step. We are in first step, and this is the front view. So this is the front view. Now this condition is satisfied. So it is resting on AF. It is this side, right? So it is resting on one of its sides, right? One of its sides, and this is now perpendicular to VP. The surface itself is perpendicular to VP. So AF, it is resting on AF. Now this should be drawn, right? So now measure this. Now this line should be reproduced at 45 degrees to HP, right? So draw a thin line at 45 degrees, right? On that line you measure this distance and replicate, right? This line should be replicated here, right? So now it is AF, so it is resting on AF, right? So this is the point AF, A1, F1, and now measure this distance and mark here, and B1, E1 can be marked here, C1, D1 can be marked here. So this is the tilted front view. This is the surface inclination. Now with respect to this surface inclination, you have to draw the final top view, right? So that is the projection now. So that is the projection, and obviously since this is 45 degrees incline, we are going to get the shape that is nothing but apparent shape only. So we are going to get a smaller hexagon than this. That is in this, right? A horizontally compressed hexagon we obtain here. So from each and every point you draw projectors from front view, and from top view also draw the projectors. Now you have to mark the points. So this is the A projector, A and C projector. So this is the A projector. So mark A1, and this is the B projector. So this is the B projector. The corresponding intersection point is your B1, and here this is C1, right? And here you get a D1 and E1 and finally F1. So now I am getting all the lines, all the points. Now I have to draw with thick lines. So this is the hexagon which is compressed. Now you can see horizontally compressed hexagon since it is 45 degrees. So this is how you should solve this problem, students. So next is a circular plane. It is a circular plane of 60 mm diameter, has its plane vertical and inclined at 40 degrees to VP. Its center is 40 mm above HP and 35 mm in front of VP. Draw its projections. So this is a simple problem, the circular plane. So we have to draw the circle as the true shape. So circle is the true shape, and the plane is vertical. Vertical means it is parallel to VP, right? And inclined at 40 degrees to VP. So inclined at 40 degrees to VP. So sorry, it is given 40 degrees to VP, right? 40 degrees to VP. So it is surface inclination 40 degrees to VP, right? So now you have to assume that the given plane is parallel to VP. So when the plane is parallel to VP, the true shape should be drawn, right, above XY reference line. So above XY reference line at what distance? So that is given. Its center is 40 mm above HP, right? So 60 mm radius, sorry, 60 mm diameter, right? So radius is 30 mm. At 40 mm you measure and draw a thin line, right? Draw a thin line. On that thin line, right, you draw this circle, right? You draw this circle and divide this into 8 equal parts, right? 8 or 12 equal parts, and 35 mm in front of it. Its center is 35 mm in front of it. So at 35 mm you draw its top view. Top view is obviously a line only, right? When you see from top, you can see from A to E and it will be a line. It will be a line. So this is A, and H is visible, B is invisible, G is visible, C is invisible. You know how to divide this into 8 equal parts, right? 8 or 12 equal parts. So these are the points, right? On circumference you mark points and then proceed. Now the surface is inclined at 40 degrees to VP. So at 40 degrees, right, you draw a line, and now this 35 mm, so that should be done, right? So from here to here, right, it is 35 mm, right? Same 35 mm should be considered here, right? So from this point to this point it is 35 mm, right? So at this 35 mm, right, measure 35 mm here and replicate this line, right, on this 45 degree line, right, on 40 degree line. So now you measure A to H, so this distance, and you mark all the points, right? You can measure from the simple top view and you can mark here. So it is obviously 60 mm, right? The diameter is 60 mm. So 60 mm line can be drawn here, but the distance should be taken care of. So this is 35 mm here also, right? So at 35 mm you should draw that, and now you mark all the points, corresponding points, and draw an ellipse. So it will be an ellipse. The final front view is an ellipse, right? When you compress the circle, obviously you will get the ellipse, right? Ellipse. So this is regarding fifth problem. Sixth one, a set square, right? It is a set square, has a shortest edge of length 40 mm kept perpendicular to VP, so that the projection of the set square on the HP, right, is an isosceles triangle. So isosceles triangle, two sides will be equal, right? Two sides of the triangle will be equal, of side 40 mm. Draw the projections of the set square and find the inclination of the set square with the HP. So at what angle you tilt with respect to HP, right, the top view of the set square will become an isosceles triangle. So it is an indirect problem. You have to solve, right, in indirect way, right? So the final top view distance is given, right? It is it is an isosceles triangle, and in what inclination you get a isosceles triangle. So that should be find out here. And with respect to HP, you have to find a theta. How much is the theta that you have to draw and highlight it. This is the set square. So this is the 90 degree here, and this is 60 degree. This is 60 degree, 60 and 90. So now if you compress it, right, at what angle if you tilt this, so you will observe an isosceles triangle, right? So that is what we need to do here. And this is a triangle, a right angle triangle, no doubt in that. So this is 40 mm, and this is 40 mm, right? If it is 40 mm, from to draw this right angle triangle, draw 40 mm line here, right? At a point, at this corner, you take 60 degree, right? That is what given, 60 degree set square. So this angle is 60 degree, students. So you have to measure 60 degree here, and you should draw a thin line, and you draw a thin line here. Both will intersect at this point B. And now draw the thick lines to complete this set square. So that is how you should build a set square, right? So now I am tilting it in order to get my isosceles triangle, right? So that is what I have to do here. And its front view, right, is a simple straight line, right? A is visible and C is invisible, B is visible. So this is the straight line. So now I have to tilt this straight line in such a way that my top view should be an isosceles triangle. So it is very simple now, right? So I know two sides are equal. So this side is 40 mm, and this side also should be 40 mm, so that it becomes an isosceles triangle. So now project the from top view, right? So at 40 mm, so this is 40, already 40 mm, and this side if I take 40 mm, this becomes my isosceles triangle, top view. So now for this, right, I need to find the theta. So that is what I have to find here, and this is 40 mm. Now you can see this is 40 and this is 40, and obviously I am getting an isosceles triangle here, and this is the point A and C, right? A1, B1, C1, and the corresponding front view points are A dash and C dash, right? Now students, measure this distance, right? Measure this distance. Now this point as center, right? On this projector you cut the arc, right? You cut the arc. So now to cut this arc, don't forget to take this distance, measure this distance, and from this point cut an arc on this projector. And now you just mark B dash, and this is the front view now, right? So now we are going in indirect fashion, right, to get the theta. Indirect problem, it is an indirect problem. So now this is the angle you need to measure. So this is theta degree, right? So what angle you are getting, so that should be measured, and you should highlight it as your final angle, right? So I am getting 53 degrees. So please check this answer, and please let me know if you are getting some other angle. So this is the theta I am finding out, and I am getting 53 degrees, students. So please verify this, right? So seventh problem, a regular hexagonal plate of side 30 mm has its surface kept perpendicular to both HP and VP. So this is the kind of problem, right, where the surface is perpendicular to both HP and VP, and draw its projections when two of its sides are parallel to HP, right? So the orientation is very important. Draw its projections when two of its sides are parallel to HP, right? So the hexagonal plate, it is kept perpendicular to both HP and VP, but it is touching HP is not given, right? So you can take any distance, right? You can take any arbitrary distance and you can draw the hexagon, right? So this is obviously side view. So now I have drawn on right side. So this is obviously the left side view, right? Left side view of this plane. So like left side view is always observed on right side, right side view is always observed on left side. So please remember this. And this is A double dash, B double dash, C double dash, D and E double dash, F double dash. Now this is my auxiliary plane, right? So this is my picture plane or profile plane on which I am getting my side view, and for this the reference line becomes this line, and this is my x1 y1. So this is how you have to start this problem. So I have got my true shape here in side view only, right? It is obviously left side view. So now it is a straight line. It is a we know that, right? We know that the front view and top view will become straight lines, two straight lines. To get the points on this projector, on single projector, we have to do this exercise. So you project this up to this projector, right? Now this is xy reference line. This is our xy reference line for this side view. So F becomes invisible, E is visible, A becomes invisible, D will be visible, right? And B becomes invisible, and C will be visible, right? So this is our front view. So to get top view, you have to do a small exercise here. First draw a 45-degree line, right? Draw a 45-degree line, right? Draw a 45-degree line, or you can do in this way also, right? You set the drafter at 45 degrees to this xy reference line and draw this thin line, right? So from A you drop down a thin line up to xy reference line and set the drafter at 45 degrees. So this is how you can do. Otherwise you can draw a 45-degree line here, and you can draw all vertical lines, and from the corresponding intersecting point of the on this line you can draw these straight lines, straight horizontal lines. Anyway you can do, right? So this is another way to do this, and set the drafter at 45 degrees. It is easy, right? Now this angle is 45 degrees, so you can set the drafter at 45 degrees. You can complete very easily, right? So this is how you can do, right? So now all these lines are parallel. It means that they are at 45 degrees to this xy reference line, right? Or 45 degrees to this line also. So it is same, right? So you can see it will be an isosceles triangle, right? So both sides will be equal. So that is how you can do this. And from each point from xy reference line you project up to this thin line to get corresponding points. And this is A, I am getting on this projector A, and on this projector I get F and B. So B is invisible, and on this projector I get E and C. C becomes invisible, and on this projector I get D. Obviously D is visible, right? So this is D, and D is visible. So this is thick line. So these are the different varieties of problems we have seen here, right? And you can refer this textbook, right? Textbook ND Bhatt, very good book for all the graphics problems. So we end up here, and that is the end of second unit. We will start the third unit also. Thank you.